Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm answering a question that was submitted by a student. I kind of like this question because it uses several properties of logarithms in sort of a little bit creative way. And so I think it's worth having a conversation about this one. So I'm just going to start off by copying this. So it's a little hard to understand the way it was submitted here. So this is log, and we're using log base 10. The common logarithm, when there's no base indicated, a 10 is implied. We don't actually need to know that for this problem, but I'm just reminding you of some of this notation and what it means. So 64 minus x squared, and then minus, and we have a big bracket here, log 8 plus x plus the log of 8 minus x. And the objective is to write this expression as a single logarithm. This is called condensing. When we're working with properties of logs, we're either condensing or expanding quite a bit. There are other things that we do with logs also, but the properties are used typically to expand or condense. So I'm going to start, actually I'm going to leave this one alone for a while. Let me just copy this one. 5 log 64 minus x squared. So in the square bracket here, see I'm adding 2 logs. So there's a property. Let me change color here so you can see. So the property that I'm going to use is the log base b. So this just generalizes it to any base. We could be base 10 that we're using now or any other base. If it were base e, it would be the natural log or ln. Anyway, the log of xy is just the log of x plus the log of y. And you can see when we write the property, we typically are writing it as an expansion where we're taking a single log and turning it into 2 logs. Here, what we want to do is take 2 logs and turn it into a single log. So we're just going from right to left here. And you can write this, because the bases are the same, the bases are 10 in both cases. Notice you have to have the same base throughout. Now we can write this as the log of 8 plus x times 8 minus x. So that's the first property that gets used. And now we're going to just leave this alone, copy this out. And I could ignore these outer brackets now, and I'm just going to foil these two. So this is the log of 64 minus x squared. Now, if you can't do that in your head, that's okay. Just take it over here. We'll put it up here, say 8 plus x, 8 minus x, and then just foil it out by hand over here, sort of on some scrap paper, and you're going to get 64 minus x squared. Okay, so now we have something that's also kind of interesting. So we have 5 of these logs, and then we're going to subtract a log from that. So it's like 5 apples, take away 1 apple. That's going to give you 4 apples. So now I'm going to write 4, and an apple is just the log of 64 minus x squared. I always like that apple analogy. Seems to help And now one more property, which is the power property. And voila, we've written it as a single logarithm, and we're using the power property, so I'm going to give you that one. Oops. Gotta write it out. Log base b of x to the a power is just a times the log base b of x. So here's a product property, a power property, there's a division property, and then there's a change of base property. And those are the four properties you need to do anything you want pretty much with logarithms. And so that's our final answer. It's a single logarithm, and there's nothing more that you can do here. And that's it for the problem, but you can see why it's kind of interesting, because we're using we're also doing some foiling and factoring and things like that going on here. Not that difficult if you know your properties. Okay, so that's it for this question. I'll see you guys next time. Bye-bye.